Welcome back, guys. Hope you had a great break. I got my Nebula mask on. It was a little cold out there this morning, so I'll take that out. A little snowy, but we can handle it today. So today, we told you before break, we're going to start reviewing for our test, which is tomorrow. And we want you to be able to explain everything we've been talking about, explain how Kepler's and Newton's laws relate to orbital. Hey guys, welcome back to school. Hope you guys had a great break. It was a little cold out there this morning. I had my face mask on. Today, we will be able to explain how Kepler's and Newton's laws relate to orbital motion. So we are reviewing for our test, which is tomorrow. We told you before break that we're going to have that test coming up. So we'll get you guys prepared with that today. We'll be doing your favorites, Kahoot, Quizzies, and a Quizlet. Just make sure you're studying those after you leave class too. The Quizzies and Quizlet will be available for you to review from, so you know what's on that test. And remember, those are reviews, so we don't give you the sheet. That's what you have to look at. So that stuff will be posted to your Google Classroom. If you have an issue with that, please let us know. And over here, spinning next to me is Mars. Today something's happening, a very special moment. NASA's InSight will be landing on Mars. So I was going to show you guys a quick video about that. So let's cue that up. And again, this is happening later this afternoon. So hopefully during one of our classes, I think this is during start 7th hour or end of 6th hour, which we don't have a class. That's when this will be occurring, and they're going to have it live on TV. So let's pull this up for you guys.
Inside Mars, that's the question a new mission from NASA is hoping to answer when it lands on the red planet later today. InSight aims to find out how warm and geologically active Mars really is. So while other Mars probes look for water or signs of life, this one is quite different.
The key question is to explore the interior of another Earth-like planet other than the Earth, or another rocky planet. And those are rocky planets other than the Earth, in order to be able to compare that planet, with the Earth. So it's a comparison that we're aiming at.
That comparison is what's fascinating scientists. Researcher Lu Pan from the University of Lyon says we really don't know much about what's beneath the surface.
We do have some guesses from our understanding of the Earth's interior. We think Mars, as a terrestrial planet, is formed more or less the same way as the Earth. So we think it has a core, a mantle, and a crust. And we know that Earth's outer liquid core is the reason we have a magnetic field. And because we don't observe this magnetic field on Mars, we think probably it doesn't have a liquid outer core.
InSight should land on a sandy area of Mars where the German instrument on board will take readings on heat flux down up to 5 meters below the surface.
It's not actually a trill, it's a penetrator. It's a jackhammer, so to speak. It has a hammering mechanism in its interior, and it's not rotating like a trill, but it's hammering straight down and into the interior to a depth of hopefully 5 meters.
First, though, InSight has to get there. It's notoriously difficult to touch down on Mars, and many missions have failed. Only NASA has so far managed to carry out a controlled entry, descent, and landing, and fingers are crossed that they can do it again this time. So that landing is crucial. Once they've managed to touch down safely, they can start to put the instruments in place and really begin to study the interior of Mars. Jeremy Wilkes, Euronews.
Well, let's stay with that Mars mission. The astronomer Francisco Diego joins me now from London. Good morning, Mr. Diego. Thank you for joining us on the program.
Good morning.
We spoke on Friday about a British mission to Mars to try and understand whether there had been life on Mars, what that might look at. What about this NASA mission? What is this one trying to find out for us?
Well, for the first time, we are looking at Mars in a different way. There are 3 different experiments on board of this amazing, very simple and cheap, relatively, lander, which is going to measure earthquakes or earthquakes to an enormous level of precision. This instrument can detect quakes produced by meteorite impacts, which is shaking Mars in a minute way. It's extremely sensitive. When they was testing it here in Europe, they could detect the waves crashing on the beach, which was hundreds of kilometers away. That kind of sensitivity, number one. Number two is this probe that is going to go 5 meters deep to measure the heat flow from Mars. to find out how Mars is releasing the heat and finding out more about this core, that is, if it is liquid or not, we just heard now. And the third one is the movement of Mars. The axis of Mars may be wobbling, and the way it wobbles, it's telling us the interior part of Mars, if it has a solid core or a liquid core or an outer core. And this wobble is being measured by accurate precision of pinpoint precision of the position of this lander on the surface of Mars. Fascinating, amazing things.
And Mr. Diego, very, very briefly, what might all of this data collection tell us about our own rocky planet, about Earth?
The formation of rocky planets is very important. Of course, we live on one of them. Mars and the Earth are very similar, although